Hey everyone, it's Liam. Welcome to another ALEKS guide. So in this guide, we're going to be naming some acids. So, couple things to note about naming acids. We're going to be referring to our nomenclature sheet again. And down here we can see that we have a couple different naming schemes for acids. So, notably, if we have something that ends in IDE, such as over here we've got cyanide, we end in IED, that is going to end up being an ic suffix. If we have something that's ending in ite, like chlorite, that is going to be an OUS suffix, so that would be, chlor, if I could spell properly, oops. That would be chlorus, right? And then if it ends in an ate, it's going to be ic again. So same as ide. If it ends in ide or ate, it's going to be IC. So, another thing to note is that when we're dealing with acids, if it has the prefix hydro, that means we're going to be dealing with an acid that doesn't have an oxygen present. So, for instance, off the top of my head, H2SO4 is called, H2SO4 would be called perchloric acid. It's not hydro because H2SO4 has an oxygen atom in it. And so we whenever we have hydro at the beginning, it means there is no oxygen present. No oxygen atom present. So let's get into this. We start with nitric acid. So we can see for nitric acid we have our ic suffix. So we know that this is going to be dealing with, it could be dealing with an ide or an ate suffix. So let's look over here. We have two nitrate. We have two options here. And as we can see, we have an option for nitrate. And we know that when we have an ATE, we always use the ic suffix. So we know that nitric acid is going to be HNO3, where this is our nitrate. Sorry, let's make that more visible. This is our nitrate, and this is our hydrogen. So, one thing to mention here is you will need to make sure that your charges are correct when you are coming up with a formula for your acid. So, in this case, we know that nitrate, if we check our charges, nitrate is a polyatomic ion with a -1 charge. And we know that hydrogen always has a +1 charge. So we got a +1 and a -1. So that means they cancel out, everything's fine, and this is our answer. Now moving on, we've got chlorous acid. So we have an OUS suffix. So if we check our table here, we know that OUS corresponds to an ITE suffix for our ion. So that's going to be chlorite. So chlorite is ClO2, and it has a -1 charge. So write this out. We start with our hydrogen, and we write our ion, ClO2. Now what about our charges? Well, ClO2 has a -1 charge, and hydrogen has a +1 charge. Those charges will cancel, meaning that HClO2 is our final answer for this one. Moving on to phosphoric acid, we have an IC suffix. So we're going to be dealing, in this case, with an ATE. And I know this because there's no, it's not phosphide we're dealing with. We're dealing with phosphate, which can be found here. Phosphate. So phosphate is PO4, and it has a -3 charge. So, going by what we've been doing so far, we write our H and then PO4. Now what about our charges? Well, hydrogen has a +1, and phosphate has a -3. So something isn't right here. Because if we add up these charges, if we've got +1 and -3, that means that our entire acid has a net charge of -2. That's not right. That's not possible. So we need to balance our compound to make it neutral. So if we have a -3 charge on the phosphate side, and we have a +1 charge on the hydrogen side, we're going to need 3 of these hydrogens in order to balance out the -3 charge. So that is a +1, +1, +1 from our hydrogens to balance out the -3 charge for our phosphate. So that is going to be our final answer for phosphoric acid. So moving on to bromic acid, we have an IC again. And we know that our IC corresponds with our ATE. And we have bromate here. So we have an ATE there, so that means bromate, BrO3, is going to be, and that's got a -1 charge. That's going to be our ion for bromic acid. So H and then BrO3. Bromate, we know, has a charge of -1, and that balances out our hydrogen just fine. So that's our final answer. Quick note, you might be thinking, Well, bromate, if 8 corresponds with IC, well, what about perbromate? Why can't it be perbromate? Well, for perbromate, we would put the per prefix in front of our acid. So if this were perbromic acid, then that would be BrO4, right? And same thing, this -1 plus 1 would cancel, so that would be perbromic acid. But because we don't have the per prefix, we know that this IC just refers to 8, which is bromate in this case. We have one other example. So let's work through this one. We have sulfurous acid. So we know that us is going to be a ite, right? It's going to have an ite suffix. And for sulfur, we know that if we check our table here, for sulfur, we have these two. We have a sulfate and a sulfite. In this case, we're going to be using sulfite, which has a -2 charge. So that's SO3. So let's write our H out, and then we have SO3. Now, how about our charges? We know that sulfate, or sulfite in this case, has a -2, and hydrogen is +1. So if we've got +1 and -2, that means we're going to have to compensate with 2 hydrogen atoms to make our compound neutral. So this is neutral, so we're good to go. Now, we have hydrofluoric acid. So here's where things get a little bit more complicated. So first of all, we have hydro in here. So since we have hydro, this means that we have no oxygen in our compound. And fluoric, we have ic again. And if we check our table, well, there's no polyatomic ion that deals with fluoride here, or any there's no FO3 or anything like that. We don't have any of that, so we know that we're just dealing with fluoride on its own. So we're dealing with this now. So IDE, fluoride, translates to IC. So we're just dealing with a singular F atom right now. So hydro, just put our H down, and an F. And that's it. There's no oxygen atoms. This F is our fluoride. And that's all there is to it. Moving on to the next one, we have hypochlorous. So we're going to be dealing with an ic again. And we have this hypo prefix here. So if we check up here, we have, first of all, we have an OUS suffix. We know we're going to have an ite ion. We check up here, we've got an ite ion here, but the problem asks for hypochlorous. So it's actually this one, ClO-. that we'll be dealing with. So ClO minus, we write out our hydrogen first, and then ClO, and we have a -1 charge there and a +1 charge there. That cancels, and we're good to go. HClO. And we actually have bromic acid again, so we don't need to do anything. And that is it.